Okay, so we've got a new group of identities here. What we mean by identities, another way we could say it is formulas, but this one here is called the Pythagorean identity, which is saying we could replace sine squared plus cosine squared with 1. For this group right here, we've got sine of two angles added together, two angles subtracted, cosine of two angles added together and subtracted, and tangent of two angles added together and subtracted. And so we're going to have something for each one of those that we can replace it with in a way that is useful, that we'll look at in the examples that follow. So on the test, you will have to have these memorized, and also you will get a formula sheet, which may seem like contradictory information, but it's not. Here's why. On the test, the first question will be me giving you a piece of paper that looks a lot like this. It's got sine of x plus y equals, and then it's just blank, and you have to fill it in. And there's a lot of other identities that are going to be on that. And then you're going to turn that into me, and that'll be the first question. That'll be for a grade. And then I will give you a formula sheet with all the correct formulas on it. This is so that just in case you memorize a formula incorrectly, you're not then using it for the whole test. I want to make sure that you actually do have the right formulas when you're doing the problems, if that makes sense. Does that make sense? So you have to have them memorized. So as we're going over this, we're going to work on memorizing it as well. And when you do homework and practice it, that will also help you memorize it. So for sine of x plus y, there is a pattern that this expands to, and it might seem a little bit crazy, but that's okay. It's going to expand like this into a pattern of sine, cosine, cosine, sine. Sine, cosine, cosine, sine. It's got, you can say it with like a little bit of rhythm, sine, cosine, cosine, sine. And that helps you remember it. Everybody say that with me. Sine, cosine, cosine, sine. One more time. Sine, cosine, cosine, sine. One more time. Sine, cosine, cosine, sine. Okay. You know how you know like all the words to all your favorite songs? You know like hundreds of thousands of words because they're to music and rhythm. It makes them easy to remember. It's the same thing with this. If you say that to yourself with that rhythm in your head as you write it out, it will stick. Now, there's more to the formula. The angles x and y just go in there. They pair up with each one of these, and they alternate x, y, x, y. And then, since it's sine of x plus y, in between these two groups here, there's a plus sign. Sine of x minus y has the same pattern, which is what? Yeah, one more time. Yes. Sine, cosine, cosine, sine. Similarly, the angles alternate, x, y, x, y. And in the middle, instead now there is a subtraction sign. This one I wrote a little far away already. Yeah. It's not always going to be x and y. A lot of times you'll see a and b as the angles there. So if it's a and b, you just, whatever they are, you put them there. Really what's going to happen is they're going to end up being numbers, and the numbers are going to go in there. So just be ready for some different variables. Okay. Cosine has a different pattern because it's different. The pattern for cosine is cosine, cosine, sine, sine. Cosine, cosine, sine, sine. Say it with me. Cosine, cosine, sine, sine. One more time. Cosine, cosine, sine, sine. One more time. Cosine, cosine, sine, sine. So you have sine, cosine, cosine, sine. Cosine, cosine, sine, sine. The angles alternate. And in the middle is actually a negative sign, a minus sign. Cosine of x minus y has the same pattern, which is, one more time, cosine, cosine. How do the angles go in? How do the angles go in? How do I put them in? X, Y, X. Just alternate. In the middle, there's a plus sign. Oops. So for these two patterns here, sine has the same sign. Sine has the same sign. It's plus, plus, minus, minus. Sine has the same sign. Cosine, this little OS right there at the end, stands for opposite sign. It doesn't really stand for that. Opposite sign. Cosine is the opposite sign. Sine is the same sign. Cosine's opposite. We'll probably do tangent next class. We probably won't get to tangent. Here's how you use it. Cosine of 15 degrees. Do you guys know the cosine of 15 degrees off the top of your head?
Ooh.
Root 3 over 2? No, that's the cosine of 30. Okay, no idea? Yeah, I have no idea what this is either. Actually, I do know because I did these notes yesterday, so I do know off the top of my head. But that's unique to today. Okay, so what we're going to do is we're going to use that identity to rewrite this as two angles from the unit circle adding or subtracting each other. So can you think of two angles on the unit circle that subtract to get 15 degrees? 45 and 30. Or? $60 and $45. Or? $135 and $120. Or? $150 and $135. Or? 45 plus -30 would also work. Negative 330, sorry, 330 plus negative 315. Okay, there's a lot of combinations. There's actually infinite combinations that we could do for this. So there's no right answer of how we're going to do this. We'll keep it simple though. We'll just do 45 minus 30. But just whatever the first one that you think of is good. Just do that. So we're rewriting 15 degrees as 45 minus 30. Then, since we now have two angles subtracting each other inside of cosine, we can expand this using the formula. And the formula goes like cosine, cosine, sine, sine. Yes. Cosine, cosine, sine, sine. And here's how I do it too. I write the pattern out first, and then I'm writing in the angles. It's not x and y this time. Now it's 45 and 30. So it just goes 45, 30, 45, 30. And what goes in the middle? Plus or minus? Plus. Cosine is the opposite sign. Okay? So we rewrote it. We expanded it. And now, do you guys know the cosine of 45? Yes, you do. You do know it. Root 2 over 2. Cosine of 30? Root 3 over 2. Sine 45? Root 2 over 2. Sine 30? 1/2. Okay. Yes, we need to know our unit circle. It's not going anywhere. Okay. Order of operations says I need to multiply these things first. When I multiply fractions, I multiply across the top and across the bottom. So that's root 6 over 4. Plus what? Root 2 over 4. Those just get added together on top of a fraction. It's just root 6 plus root 2 over 4. You can't add root 6 and root 2. You can't add radicals unless they're the same thing inside. We just leave it like that. Okay. Our process, here's our process. Step 1 was rewrite with unit circle angles. Step 2 was expand using the identity or formula. Step 3 was evaluate and simplify. I guess you can call that steps 3 and 4 if you want. Actually evaluating the unit circle angles and then adding them together. Very straightforward process. Actually quite different than doing like a proof, right? A proof, you have to kind of figure out what to do. Here it's just like, oh, I just do this. Do this every time? Yes, do this every time. So for number 2, sine of 165. Step 1, rewrite with unit circle angles. How do we rewrite this? Turn your partner, what angles could this be? Okay, what angles could we use? Okay, 210 minus 45. That would work. Did anyone have a different idea? 120 plus 45. Yeah, okay. We're going to get the same answer for both of those. It does not matter which angles you do, you will get the same answer. Okay. Now I'm going to expand using the identity. So we have sine of 2 angles subtracting each other. What's the pattern for that? Sine, cosine, cosine, sine. Here we go. Fill in the angles. They alternate. 210, 45, 210, 45. I would not have thought of 210 and 45. But you know. All right. What goes in the middle? Minus. Sine is the same sign. Sine, same sign. Okay, 210 is this angle right there. It's 7 pi over 6. What's sine of 210? Negative what? 1/2. Negative 1/2. Times cosine 45. Root 3 over 2. Minus cosine 210.
Wait.
Huh? Oh, yeah, sorry. Root 2 over 2. I was thinking of cosine of 210. That's how I was. Cosine 210? Negative root 3 over 2. Sine 45? So we have negative root 2 over 4 minus negative root 6 over 4. I like to write it this way. It doesn't really matter the order, but I like to do positive root 6 minus root 2. I like to put the positive number first. Just looks better, I think. But it doesn't really matter. So the process, rewrite with unit circle angles, expand using the formula, substitute in using the unit circle, evaluate it, and simplify. Questions? Okay, you guys do numbers 1 and 2 on the bottom of the page. Ready, set, go. All right, let's check these. Step 1. This is sine of what? What do you guys do? 45 minus 30. All right. Then we expand. What's the pattern for sine? Sine, cosine, cosine, sine. Fill in the angles. 45, 30, 45, 30. What goes in the middle? Minus, yeah, sine is the same sign. Okay, a lot of the same angles that we did in the first problem. So sine 45 is root 2 over 2, cosine 30 is root 3 over 2, minus root 2 over 2 times 1/2. That's root 6 over 4 minus root 2 over 4. Root 6 minus root 2 all over 4. Questions on that one? All right. How do you guys do 285? Huh? 240 and 45. Nice. 240, I always have to remind myself is that one right there. What's the pattern for cosine? Cosine, cosine, sine. 240, 45, 240, 45. What goes in the middle? Minus, yeah, the opposite side. Cosine 240 is negative 1/2. Cosine 45 is root 2 over 2. Sine 240 is negative root 3 over 2. Sine 45 root 2 over 2. Here's one thing to pay attention with in these is negative signs. Just pay attention to the negative signs. We have a minus, a negative right here, so that's going to become a plus. We have a negative sign out front. We have root 6 minus root 2 all over 4. If you wrote it as negative root 2 plus root 6 over 4, that's the same thing. That's equivalent. Same exact number. These last three problems, we got the same exact answer. Is it normal for sine and cosine to have the same value at different places? Like 1/2 root 3 over 2, root 2 over 2. Yeah. So here's what's going on is 165 is like right here. So that's a pretty small y value. Sine of 15 would be right there, which is the same very small y value. That's why they have the same sign. They're both like 15 degrees up from the axis. Cosine 285. 285 would be right here, which would have a very small x value, since it's only 15 degrees to the right of straight down. That's why all these angles have the same coordinates there. It's because they're either 15 degrees up or 15 degrees out. So it's a fun fact for you. Take it or leave it. Let's go to the back. Okay. Number 5. So the directions here are giving us a bit of a hint by saying condense. Condense is the opposite of expand. This could just say evaluate, though, which is a little more ambiguous. It could just say evaluate. So here's what we want to notice when we look at this. Do you know the cosine of 85?
No.
No. Do you know the cosine of 25? No. Okay, me neither. So first of all, I would notice I don't know the cosine or sine of those numbers. The second thing I would notice is the pattern. What pattern do you see? Cosine, cosine, sine, sine. Oh. Cosine, cosine, sine, sine, which means this is cosine of what? Subtraction. Because it's plus sign, so it's what minus what? 85 minus 25. Condense. That equals 60. What's cosine of 60? 1/2. Hey. How about that? There's a couple questions like that on your homework as well. Okay. Cosine of pi over 12. Do you know that? Yeah, I don't know it either. Actually, I do know it, but I don't know it either. Can you think of two angles in radians that add or subtract to get pi over 12? First of all, is that bigger or smaller than pi over 6? Smaller. Okay. Think of any angles that subtract to get pi over 12. Huh? Okay, divide pi over 6 by 2. That is something that we're going to do later, called a half angle identity. That is going to be a different kind of crazier formula. So we won't do that for right now. That is another way that we could do this. We won't do that. But it is half of that, which means it's how many degrees, by the way? It's half of pi over 6. 15. Oh, this is 15 degrees. But we already know the answer. Yeah, we do. We do already know the answer. But 15 we know is 45 minus 30, which means that pi over 12 must be pi over 4 minus pi over 6. Do you guys follow? This is 45. That's 30. If I subtract them, I should get 15 degrees. If you think about it this way, if I get a common denominator, that's 2 pi over 12 and 3 pi over 12. What's 3 pi over 12 minus 2 pi over 12? 1 pi over 12. Yes. To subtract two angles, I need a common denominator. My common denominator is 12. Pi over 6 is 2 over 12. Pi over 4 is 3 over 12. Pi over 3 is 4 over 12. I could do 4 minus 3 over 12, or I could do 3 minus 2. I just went with 3 pi over 12 minus 2 pi over 12, which is really pi over 4 minus pi over 6. So I'm rewriting that with two unit circle angles. What would be my next step? Cosine, cosine, sine, sine. Yeah, we did already do this on the other. It's root 6 plus root 2 over 4. I want to make sure we get to the problems at the top of this page. Okay, we're going to look at number 3 at the top. So number 3, we're given some information about 2 angles. They are alpha and beta. That's what these symbols are, alpha and beta. So sine of alpha is 3/5, and alpha is between 0 and pi over 2. So what quadrant is that? That is quadrant 1. So we're going to draw a triangle for alpha. And remember that sine is y over h. So that means this is going to be 3 over 5. We're also going to draw a triangle for beta. We're told the cosine of beta, and we're told that beta is between 0 and pi over 2, which means it's in which quadrant? First quadrant. Same thing. Remember, we want to draw our triangles like this. Remember, cosine is x over h. So this would be 5 over 13. What would the missing sides of these triangles be? 4 and not 7. 6. Nope, not 6. Nope. 12. These are common right triangles. 3, 4, 5, 5, 12, 13. Helpful to have memorized. We want to find sine of alpha plus beta. So we're going to expand that. Sine, cosine, cosine, sine. Alpha, beta, alpha, beta. The plus sign in the middle. So then now we're going to evaluate. So now instead of them being unit circle angles, we have the pictures of the angles right there. So it's very similar process. Take the formula, expand it, evaluate each little expression there. But it's not unit circle, it's those angles right there. So what is the sine of alpha? Uh, 3 over 5. 3 over 5. So it's only the y-coordinate on the unit circle. Cosine beta. Five over 13. Plus cosine of alpha. X over h. 4 over 5. Sine beta. Y over h. 12 over 13. Okay. Sine, remember, is y over h. So 3 is the y-coordinate, or 12, depending on the angle. H is the hypotenuse. Cosine is x over h. In order to add these fractions together, I need to have a common denominator. Luckily, they have one already, so that's 15 over 65 plus 48 over 65, which just equals 63 over 65. Okay, I'm about to give you guys the homework. On the homework, we're going to do questions 1 through 4, 1 through 6, 9 through 12.
check that.